Okay, as we start with problem 19, I had a lot of people who tried to do this material over the weekend, and they did most of it incorrectly. And it really comes out to them not implementing the strategies that they've learned in algebra. For example, as you see this problem, 8 sine squared of theta equals 7 sine of theta, most everybody wants to do something right away that is ultimately incorrect. It's the same thing I did when I first saw these problems back when I was your age. Anybody want to do something to both sides? If we divide both sides, don't do this on your paper. If we divide both sides by sine of theta, you get 8 sine of theta is equal to 7. And then you get sine of theta is equal to 7/8. And there's only two solutions to that. That's a problem. There's supposed to be 4 solutions to this problem, or possibly more. Sorry, my contact's bothering me. I gotta shut it later. So what we need to do instead is we need to use a zero product property. And in order to use a zero product property, I need to set the function equal to 0. So 8 sine squared of theta minus 7 sine of theta is equal to 0. And sine squared. So it's kind of like this. A times B is equal to 0. If we can write two things as factors, meaning as multiplication, then I can use a zero product property where something times something is 0. If A times B is 0, then we either know that A or B is 0. So as we factor this, how would you factor it? Take out a sign. Sine of theta times 8 sine of theta minus 7 equals 0. Now I have two terms that I can work with. Namely, this one that says sine of theta is equal to 0, and 8 sine of theta minus 7 is equal to 0. Now I can solve for both of those. That's the correct way. Don't divide, okay? Don't divide a sign off of both sides. Where is sine of theta equal to 0? It's equal to 1 at 90. It's equal to negative 1 at 270. Where is it equal to 0? 0, 180, 360. So again, we're solving for angles between 0 and 360 for this problem. And then 8 sine of theta minus 7 equals 0. This is good review from Friday. What did we do here? Add 7, divide by 8. You get sine of theta is 7/8. What do I do next? Draw my 4 quadrants. Where is sine positive? 1 and 2. Take out my calculator. Make sure I'm working in degrees. My broad shoulders are in the way. Ooh. Nathan says I have narrow shoulders. Maybe Nathan will like to sit down and bench press someday after school. All right. We will do it. You will never call my shoulders narrow again. All right, here we go. So I go second sine 7/8. And I get 61.04. Now, I really want to be clear about this. When you do second sine of theta or second cosine of theta, you know, whatever you want to do, you do that inverse operation. That allows you to find the reference angle. So I draw whatever angle they give me, which in this case is 61.04. What is then the reference angle? 61.04. In this case, it happens to be the same. But when you do that, it doesn't just give you the reference angle. It allows you to find the reference angle. So now I draw another angle over in this quadrant, 6104. And those would be my two angles that I will use. So my first angle is this one in red, and my second angle is the other one in red. So that first angle is 61.04 degrees. How do I find the second one? 180 minus 61.04, which is 118.96. So we have 5 solutions here between 0 and 360. 0, 180, 360, 6104, and 118.96. How do you like them apples? Well, yeah, I said 4. There are 5. Sorry. See if you do 20 on your own. Start 20. I'm going to go put my eye back in. I'll be back in a second. Too much conversation about contact lenses. So my sophomore year football, I'm out on the field. I play quarterback. I got hit and tackled, and all of a sudden I get up and I'm like, shoot, one of my contact lenses popped out. You know, they're $100 a piece. So I'm like, you know, I mean, you're in the middle of a football field. So I said, hey guys, I said, I don't, you know, we're in the middle of practice. I said, you know, coach, I don't want to take a long time, but can we at least just look down on the ground and see if we see it? So we looked down on the ground, and Tavish Schlicker says, oh, I see it. It picks it up and gave it to me. I quick looked it, stuck it back in my eye. I'd rather have my saliva on it than you know, dirt. So yeah. So yeah, pretty ridiculous. Anyway, all right. What do you do first? Factor out a secant. And you'll be left with 2 secant squared of theta minus 5 is equal to 0. We now have 2 expressions that we can set equal to 0. Secant of theta equals 0. And 2 secant squared of theta minus 5 is equal to 0. So that means secant squared of theta is equal to 5 over 2. Let's start over here on this side, though. I don't like to work with secant. I like to work with cosine. So we take the inverse. So we got for the reciprocal. So the cosine theta would be equal to, what's the reciprocal of 0? Undefined. Undefined is the reciprocal of 0. Where is cosine of theta undefined? Never. So there's no solution for that part of it. Okay? Get rid of it. We don't need it. No solutions for that portion. But over here, we could say that cosine squared of theta is equal to 2 over 5. Square root both sides and get cosine of theta is equal to plus or minus square root of 2/5. Where is cosine positive? First and fourth. Where is it negative? 2 and 3. So I do cosine inverse of square root of 2/5. I get 50.77. That's a 50.77 degree angle. So you have 4 angles there that you're finding. 50.77. Then you have one of the second, one of the third, one of the fourth. What do you think? Michael doesn't like that one. We lost an hour of sleep. It's tough. Tough to lose an hour. Okay, you guys got the rest? What do we got? Whoop. There you go. So we would add 50.77 to 0. We would subtract 50.77 from 180. We would add 50.77 to 180. We would subtract 50.77 from 360. Okay, one more. Let's do 22. Yeah. Actually, let's do 23. I like 23. We got to factor that. A lot of people wanted to subtract the 6 from both sides and then take out a cotangent. Can't do that. We got to use a zero product property, and it's equal to 0. Now, some people couldn't remember how to factor this stuff. And so I'll show you, in case you're not very good at factoring, I'll show you how to factor it using the AC method. The AC method says you take that 5 times that 6 and rewrite it as cotangent squared of theta plus 31 cotangent of theta plus 30 equals 0. Now don't worry, we'll get back to that 5 in a little bit. Now factor this. That factors to cotangent of theta, cotangent theta. What? What two numbers multiply 30 to add a 31? Plus 30 plus 1. What do you do with that 5? You put it back in. And you look at your result. So I know this is a little bit different than how Miss Nelson taught, but this is the way I like to do it. I put the 5 back in. Are 5 and 30 both divisible by something? What? They're both divisible by 5. So divide both these by 5, and you will get cotangent of theta is equal to, or I'm sorry, plus 6. Cotangent theta plus 6. Are 5 and 1 both divisible by the same number? No. So you have 5 cotangent of theta plus 1. So now it's factored properly. No, because 5 and 1 aren't divisible by 5. That's the AC method. So now I set both these equal to 0. So I have cotangent of theta is equal to -6. And I would have 5 cotangent of theta is equal to -1. Divide by 5. Cotangent of theta is equal to -1 over 5. I don't know how to work with cotangent. So what do I do? Tangent of theta is equal to -1/6. And tangent of theta is equal to -5. Now, you guys, this is where I come to a point where second hour, they told me that I should teach it differently to you guys than I taught to them. They said that they wished I would have done it this way all along. So I'm going to just deviate for a second, okay? It's nothing big, but just watch how this works out. Where is tangent negative? 2 and 4. Tangent is negative 2 and 4. So I'm going to have 4 spots, right? Here's what they told me to tell you to do that I told them at the end of class. They said that they like this more. See that negative sign? We've used that to identify which quadrant we are in. If I then go to my calculator and I type in inverse tangent of just positive 1/6, forget about the negative. The negative was, that told us our quadrants. If we just type that in, it will always just give you the reference angle then. So my reference angle is 9.46 if you would have done negative, you would have come up with negative 9.46 in this situation. But there's situations that involve cosine and secant that numbers come out differently. They told me that they wished that from the beginning I would have just told them to do that, because they were running into some problems with some other things. So I'm going to try that. That's the way I taught regular track how to do it last year when I taught trigonometry. But I want you to understand why when you punch in cosine inverse of -1/2 in your calculator, why you get 120 degrees. They said that they don't really care and they would rather just see this. So that's what we're going to go to. So here I can do tangent inverse of. The negative told me which quadrants they're in, so now I'll just type in +5, and that gives me my reference angle, 78.69. So now you can, add and subtract from 180, 360 in order to figure out those numbers. But 180 minus 9.46 would be 170.54 degrees. And then subtract that from 360, we get 350.54 degrees. And then same thing over here, we get 91.31 degrees. And I'm sorry, 101.31 degrees. And 281.31 degrees. So there's our 4 solutions. So that's what I want you to practice. That's all I got for you. I will now come around and answer some questions. Remember that tomorrow we're going to try some harder problems yet. Wednesday, workday. Thursday, study guide. Friday, tests.